Hello, everybody, and happy Tuesday. If someone could do me a huge favor and just raise their hand if they can hear me, so I'm sure that my sound is functional. That always helps. Okay, thank you, everybody. So let's get started. No time to waste. As you all know, I apologize profoundly for scheduling this class tonight, but at the time that we scheduled this, I didn't know that the Warriors were going to be playing in the NBA Finals right now. And so I have a sense of urgency to get through this material very quickly so I can watch the game. I'm kidding. I've got it on record. The only rule for tonight is number one, if you're from Toronto, sorry, we're going to crush you. Number two is don't say anything about the game. Don't type into the chat box like, oh, the Warriors are up by 10 points, because I don't want to know. It's on record, and I just want to start fresh when this is over. I'm going to watch it. So no giving away anything about the game. And let us talk tonight instead about the 3 stages of GI dysfunction. And there's a lot of really fun and great microbiome things going on now. I just returned from the Institute for Functional Medicine's annual conference, and many of you may have been there as well, and was really excited to be talking to all the lab directors for the GI map test. Tony Hoffman and David Brady had long conversations with both of them, with Daryl Hickok, who's in charge of doctors' data, has run that lab. He's second generation. He's been running that. His family's been running that lab for like 100 years. The Genova GI effects test. So it's a very interesting and exciting time for us right now. All three of these companies are in a bit of an arms race now to get the best microbiome testing out. So if you haven't seen these things yet, I'll show you real quick here. There's a brand new GI map that just came out. I saw it for the first time on Thursday last week. And they've got the regular stuff you may be used to if you've been doing a lot of these tests. But then they added to the GI map my favorite commensal bacteria, Akkermansia mucinophilia, which we're going to talk about tonight, Clostridia as a class, Faecalibacterium prausnitzii, and of course they already had Lactobacillus, which we're going to talk about in a moment, Bifidobacterium, and Bacteroides. Okay, so these ones that I'm circling here are super important. We're going to talk tonight about them for the whole time. Again, I'll mention the names so you just get familiar with them. Akkermansia mucinophilia, which they just added to the test, Bacteroides species, Bifidobacterium, Bifido we get when we buy the probiotics, right, for patients. Clostridia, that's not the bad Clostridia, that's good Clostridia as a class. I think there's some 600 Clostridia organisms, very important part of the healthy microbiome, okay? And then we have Faecalibacterium prausnitzii, and then again, the famous one, Lactobacillus. Again, you can buy supplements with Lactobacillus. You can buy supplements that have Bifidobacterium. So then the question is, when you see these other markers abnormal, what are the things that you can do to build up Akkermansia mucinophilia? What are the things that you can do? And what does it mean when Bacteroides is low or high? What does it mean when Clostridia is low or high? And what can you do about these things? What does it mean when Faecalibacterium prausnitzii is low or high? This is like the essence of the microbiome. So again, the GI map folks are adding to their test as of last week. They've got all these new markers they've put on. And there's a couple of other new ones here under opportunistic bacteria. These are brand new markers, Methanobacteria, and there's one other, I can't remember the name of it now. But anyways, so this is interesting, right? Because these guys are adding new markers all the time. If you've seen the latest GI effects tests from Genova, they are also adding new markers all the time. And this is all with the DNA testing, right? And then doctors' data is going to come out with a brand new microbiome test sometime this summer. So it's a very, very exciting time. I imagine this is how Lou Van Hook felt. You remember Lou Van Hook? He's the guy that invented the microscope hundreds of years ago. So you can just see Lou Van Hook walking around, and he kind of knew how to make lenses. And he's like, wow, I can make a lens where I can see stuff that's really small. And then he was the first human being in the history of human beings to actually see bacteria. It's like, whoa, what is going on here? And people thought he was crazy at first because no one else had the lens making capability that he did. So they were just thinking he was a crazy person making up stuff, that there are these little organisms moving around that no one else could see except for him with his special little lens. And this went on for years. People thought he was nuts until other people figured out how to make the same quality lenses, and other people started to see bacteria moving around, right? So what's happening right now, this arms race with the labs, is they're all onto this PCR testing. Okay, so this is PCR, polymerase chain reaction testing. It's a DNA-based test platform, and there's new technologies coming out for these DNA platforms. Like I said, this summer there's going to be a big new one released by Doctors Data. GI Map is a relatively new company. If you haven't used them yet, I strongly recommend you try them. And then Genova, kind of the old school company, is adding more and more PCR to their test as well, their GI effects test. So it's a golden time now. Again, we're rather than looking under the microscope like we have been for generations, right? Now we're able to see these organisms with these DNA tests. So I want to talk more about the microbiome and what the implications are of the fact that now we can measure these things. And remember, what we're going to talk about tonight primarily are the commensal bacteria. We're not talking about the pathogens. We can talk about that some other time. The commensal or normal bacteria. And what's so significant about these is that we're talking about them as they exist in the large intestine. And the important point we're going to come back to over and over tonight is that this is an anaerobic environment. There is not a lot of oxygen in your large intestine. So these organisms grow in an anaerobic environment. And so back in the day, prior to PCR testing, prior to this DNA testing, labs would do cultures, right? And they would try to grow out organisms in a petri dish, in a culture, in a lab. But obviously the lab had a lot of oxygen. So it was very haphazard. What would grow in the lab that they would report back on the cultures was massively influenced by the presence of oxygen. Now with the PCR testing, we can get real-time numbers on what organisms are where in your gut. With the DNA testing, you're actually seeing what's growing in the gut in the absence of oxygen, right? So it's an infinitely more accurate test that we're looking at now, right? And the new ones that's coming out in the summer are going to be an even more, sort of rigorous and intense platform. So I want to talk about this tonight and kind of get us all warmed up. We'll probably do a series of these. And I've divided the treatments into 3 stages. There's me. And looking at these as progressive, okay? From the microbiome to the organ dysfunction to the pathogens, and how you can get a grip on, what these new test results mean and how we're going to incorporate them in. Oh, and then shameless advertising. We have a mentorship class coming up next sometime this month. It keeps getting better. So it's a 1-year program. Primarily, most people do the 1 year. We look at hormone evaluations, but particularly the adrenals. We do a lot of work around the gut, like we're talking about tonight, and a big emphasis on organic acids. Richard Lord, if you guys are familiar with Richard Lord, who is Richard Lord? He's the guy that wrote this book, which is really the only major text in our industry laboratory evaluations. So Richard has joined my faculty now, and he's teaching some of the senior classes every week for the more advanced students. It's a great time to be involved. We have a really active community, and if you sign up by June the 10th, you use that promotion code, you save $1,000 off the year-long program, and the class starts really soon, actually, June 11th. Okay, so contact us if you're interested in starting the class. If you're interested in saving some money, you can have that promo code. If you lose the promo code, just remind us, and we'll honor it. All right, so now I'm going to talk. Here we go. So I just put this slide in so I don't forget to mention that we're looking at one sort of isolated thing now. We're looking at the microbiome primarily tonight, and we're not ignoring the whole rest of the environment that we're dealing with, because it's it's a microbiome but in a context. And when I think about these GI tests, I think about really 3 major steps. I'm going to skip some of these slides because they're not really relevant for tonight. But I want you guys to be able to understand like what these 3 stages are, how to identify what the stage the patient is in, and then where you want to start in terms of treatment. And so I think stage 1 is microbiome problem. Stage 2 is there's a GI organ issue. And stage 3 is there's a pathogen. And as you get better and better at doing this, you may want to mix and match the different stages that you're treating. If you're relatively new to GI testing, you can start simple and just work with the microbiome. If your patient has really mild symptoms, you can start with stage 1 and just work with the microbiome. If the patient is super sick and you're super advanced, you can skip right to the end and do stage 3 stuff and look at the pathogens. But the point of the new work that's being done in our industry around all these tests is that now we're able to actually analyze the microbiome and address it directly. And we don't have to just look at pathogens and kill pathogens. We have more possibilities, more potential now. And in the work that I've been doing in the last couple of years with Dr. Lord and the training he's been giving me, there's this really big focus he has on normalizing the microbiome, okay, as a first step. Secondly, as looking at the organs like the gallbladder, the pancreas, getting them working properly. And then, as a last resort, potentially thinking about killing pathogens. And it's interesting to me with some of my sickest patients, sometimes the microbiome correction works better than killing the pathogen. Okay, so it's not just that you would do a stage 1 treatment for the microbiome with an easy patient. Some hard patients, as you all may know if you've been doing this a while, can't handle the pathogen treatment, and you're better off starting off with the microbiome treatment in the first place. An essential tenet of Richard Lord's work right now, the last 5-10 years, is that it's the microbiome that triggers this whole thing. The collapse of the microbiome is a reason why people end up with GI organ problems. It's why they end up with leaky gut, and it's why pathogens eventually become a problem. So if we're really looking at the root cause of these GI issues, we got to dig in and start to think about how can we correct the commensal organisms. And this to me is super cool, super new stuff. I just want to mention something that came out last week before I forget, and that is a GI platform. So I've been working on this, I don't know for how long. Well, kind of indirectly for 3 years. And it just got released last week. So it's from Pure Encapsulations, one of the companies that I really strongly support. And they support me, right? They pay me to talk about stuff. And I'm super happy to do that because they have really great products. And so we came out with this Pure GI platform, and I'm like the spokesperson for it. And so you should just know that this stuff is out there. Some of these products are unique, some of them aren't. What's unique here is really kind of revolutionary, I think, is the butyrate, the sun butyrate product. So no one's ever really been able to produce a butyrate that completely bypasses your stomach acid. And now this one, all the research shows 90% of the butyrate gets into your gut. And so this is a game-changing product. It's just coming out now. They just released this last Thursday, okay? There's also a really cool probiotic. I developed this prebiotic powder, polyphenol prebiotic powder. You'll see why in a minute. And then there's some other like symbiotics, this kind of combo product of prebiotic and probiotic together. And the idea behind this whole line that's coming out here is what can we do to support the microbiome? Let's not just try to kill everything all the time like we have been, but maybe there's a deeper way we can address this. And I'm most excited about the butyrate product and the potential that this has. So that's something you can read about later, okay? We'll talk more now about why butyrate is important and how it should be getting produced in the body. And for those people that can't produce it, we can use it in a supplement form. And I think the way that I see the butyrate specifically is that if the person is low in butyrate on the labs and they can't make it because they don't have the microbiome organized enough, healthy enough to make it, then we can use butyrate for 3 months, 6 months, maybe a year at the most, as a way to bypass the problem, get those intestinal lining cells to heal and function properly, and then obviously you make the butyrate from, fiber in your food. But a lot of these patients that we work with can't consume the fiber, or they have been consuming fiber in the form of fruits and vegetables for a long time, and they're still not making the butyrate, right? So this is kind of like a breakthrough product that I'm pretty excited to be getting involved with. All right, so let's look at some of the science behind all this and why this stuff matters. The first stage of dysfunction, again, this is classic Richard Lord. He's been working on this for 15 years, really. The microbiome and why. It all comes down to basic stuff that we don't really want to think about because it's so basic. Lack of fiber in the diet, lack of polyphenols in the diet. And we can see both of these on labs, and we'll look at those in a minute. Poor eating habits, obviously you talk to the person about that. People are eating on the run. They don't take time to digest. They're drinking a ton of water when they eat. They're not chewing their food. You know, poor eating habits, no matter how much you supplement, you're not going to be able to supplement and correct for poor eating habits, right? So it's really important we talk to people about how to eat and how to relax when they're eating. And then all these things combined together, lack of fiber, lack of polyphenols, and people being on the rush when they're eating are going to lead to a collapse of the commensal bacteria. And so on the correction side, you got the choice of prebiotics, probiotics, and fiber. And most importantly, getting people to eat fiber-rich foods like beans, getting people to eat foods that have fiber and polyphenols like vegetables and fruit, right? So there's a supplement solution and a diet solution. So let's take a look at, oh gosh, is this slide? Yeah, this is right. Okay, so the first part of this was to realize that there's 3 general categories of these bacteria. 3 general categories. So there's the commensal bacteria that are going to respond to fiber and polyphenols. And these bacteria have a really specific job. They take fiber and they convert it into fat, fiber to fat. What a strange thing. It's amazing that they can do this. So we eat dietary fiber. We can't break the fiber down. I mean, we're not like cows, right? We don't have like 16 stomachs. So the bacteria in our gut take these fibers and they convert them into fat. Try to figure that out. How could you convert fiber into fat? We call these fats short chain fatty acids, but they're fats, okay? And so these bacteria are not doing this to be nice. These bacteria are doing this because they want the fiber. They use the fiber as a fuel supply, and what they spit out as a waste product are these fats. One of the chief fats then, of course, is butyrate, all right? And that is the main fuel supply for our intestinal cells. So in other words, our intestinal cells rely upon these short chain fatty acids like butyrate coming from these specific bacteria in order for us to function. And if you don't have enough fiber, you don't have enough short chain fatty acids like butyrate, and your gut is going to get damaged. You know, you can have all kinds of inflammatory problems, immune system problems, the whole system starts to dysregulate. So what are the bacteria? And we already mentioned these a minute ago. What are the bacteria that are really good at taking fiber and making fat? Here they are: Bifidobacterium, Faecalibacterium prausnitzii, Lactobacillus. Okay, there's a few others here, but not every lab company tests all these. So I'm just highlighting the ones that are super important because you'll see these on the various different companies. You'll see this on the GI effects. You'll see this on the GI map. You'll see these on the doctor's data test. Okay, so Bifidobacterium, Faecalibacterium prausnitzii, and Lactobacillus. These guys are cranking away, taking fiber and making short chain fatty acids. So stands to reason, if you see low short chain fatty acids or low butyrate on a lab, you should look and see what's Bifido doing, what's Faecalibacterium prausnitzii doing, and how's the Lactobacillus. Now, 2 of these are easy to fix. Bifido and Lactobacillus, you can just buy supplements that have Bifido and Lactobacillus in them and just have the patient take the probiotic, right? With the Faecalibacterium prausnitzii, I don't think you can buy that in a supplement package, right? So you're stuck either getting the person dietary fiber and polyphenols, okay, to get those bacteria up. So again, here's this basic sequence of events. We eat the fiber. The short chain fatty acid producers need that fiber. They're going to die without the fiber. Those short chain fatty acid producers are in turn going to stimulate these other group of bacteria that produce hydrogen. And then the hydrogen that this group makes is consumed by another group. So there's 3 things happening here, okay? There's one group of bacteria that make the short chain fatty acids. There's another group of bacteria that produce hydrogen. And there's a third group of bacteria that consume the hydrogen, okay? And I actually have a chart on this, wouldn't you know? And it's color-coded because I like things that are color-coded. So let's look at this real quick. You don't have to memorize all this now, but just the general understanding. Once you understand this, it's so cool. You'd be able to help so many people. So number one, these are in blue are the organisms that produce short chain fatty acids. Remember Bifidobacterium, Faecalibacterium prosnitzi, Lactobacillus. In green are the hydrogen producers. And the ones that we just saw in the lab a minute ago, Clostridium species, remember that? Bacteroides, you remember that? Okay, so Clostridium, the good Clostridium, not bad, and Bacteroides, these organisms produce hydrogen. And we'll talk about why that's important in a minute. And then these guys here, the fancy term is hydrogenotrophic, but these are the ones that consume the hydrogen. Methanobrevibacter smithii and Desulfovibrio pyger. And then this guy here, we're going to talk a lot about. Akkermansia is super special. It does a super special thing. Okay. So again, the blue guys make short chain fatty acids. They're the energy source for your intestinal cells. Without those, your gut is inflamed. Without those, your gut immune system just falls apart. The green guys make the hydrogen, and these red guys consume the hydrogen. So if you see a red guy low, it could be because the green guys are low and they're not making enough hydrogen. All right. If you see the green guys low, it could be because the blue guys are low because you're not getting enough fiber. So these organisms are kind of existing in different groups and they're dependent on one another. The hydrogen consumers need the hydrogen producers, right? And so on and so on. Oh, I did that wrong. The hydrogen consumers need the hydrogen producers here. And so it's a ricochet effect when you start to see one of these organisms fail, or one or more of them fail on the lab. All right, so let's get back here. Sorry, I got so many windows open now. It's a little crazy. So potential beneficial effects of butyrate in intestinal and extraintestinal disease. This is an old study, but hey, I think it's kind of cool because it has nice graphics. So at the extraintestinal level, butyrate is really important for insulin control, for cholesterol production, for energy or metabolism, so you get fat if you don't have enough of it. It helps detoxify ammonia. It helps with cardiovascular function, with brain function. It just goes on and on and on. Inside the gut, it's really important for all these other things, but there's a better picture here I'll show you. It's really profoundly involved in, here we go. Again, this is butyrate from fiber. These bacteria that I mentioned earlier convert fiber into these fats like butyrate. And then butyrate itself has an anti-inflammatory function. It prevents oxidative stress. It helps modulate cell growth. That's a fancy way of saying it helps prevent cancer. It's very, very strongly involved in intestinal motility. It's massively in control of the immune regulation system. It helps with absorption. And of course, you're going to have damage to the gut or leaky gut if you don't have enough of this butyrate floating around for your system. So super important that we get the fiber, okay? And butyrate is sort of the emblematic as the number one short chain fatty acid that we need. Patient doesn't have it, you can give it in a supplement. Obviously better to do this with diet. Okay, so that's category one. Short chain fatty acid bacteria. Let me go back here and show you which ones they are, so in case you forgot. Because you got to see these, I think, a bunch of times. So remember, the short chain fatty acid producing ones are up here in the blue. Bifido, Faecalibacterium prosnitzi, Lactobacillus. Okay. Now we're going to talk about the green ones. These are the hydrogen producing bacteria, ones that crank out a lot of hydrogen. What are those? Clostridium, Bacteroides, remember? So let's take a look at those guys here. So improving commensal bacterial markers determine the status of the major hydrogen producers. Clostridia, Bacteroides. Okay. The hydrogen producers require the fiber. There's ones that are in high abundance, and in other words, there's a lot of them. There's ones that are in lower abundance. And you can see here the ones that we're most kind of keyed into, because all the different lab companies are reporting these now. Bacteroidetes and Clostridia species are the major hydrogen producers. The hydrogen consuming bacteria need these guys or they don't have their hydrogen. And there's a bunch of reasons why this is really important. Again, the high abundance, that means there's a lot of them, high abundance, hydrogen producing bacteria, Clostridium. Rosbergia is not tested by everyone. The GI effects test does do that one. And the Bacteroides. Okay, high abundance, meaning that there's a lot of them present, hydrogen producing. So we'll talk a little bit more about hydrogen in a minute. So you also want to, in the beginning here, you're looking for short chain fatty acids, you're looking for these hydrogen producers, hydrogen consumers, all this stuff. You also, in the back of your mind, or maybe in the front of your mind, you want to understand how to identify these polyphenol markers on an organic acids test. I don't think this is very well taught. At least the way that I learned this stuff was backwards. And it's frustrating when you learn something backwards and it's kind of wrong. So let me try to clear this up. It wasn't really until I started to work with Dr. Lord that I was like, oh, I learned this backwards. So the way that I learned this is that benzoate, hippurate, phenyl acetate, all these markers, if they're high, are bad. Is it SIBO? Not really, because this is large intestine, but it means that there's overgrowth of bacteria. So if these markers test as a pattern high on organic acids, you kind of think that there's dysbiosis going on. Maybe you should kill something, maybe not. Maybe you should just give some ox bile to calm things down. I don't know. But anyways, high is bad, right? And honestly, the way that I learned this 20, 25 years ago was low was good. I always just assumed that low was good. You would think that looking at the report, because there's no red zone on the low level, right? They don't tell you this on the report. You're supposed to know this mystically somehow. And then the way they say it here, the title compounds of bacterial or yeast fungal origin, kind of makes it seem bad because we always think yeast and fungal organisms are bad. But let's take those words out. These are compounds of bacterial origin, this section of the test. And if these markers are low, these are all polyphenol markers. If these markers are low and you see a pattern of low markers on organic acids, what does that mean? It means that the person is low in polyphenols and they have a lack of good bacteria growth because of a lack of polyphenols. High is bad, okay, it's dysbiosis, but a pattern of low markers here, benzoate, hippurate, phenyl acetate, you get the phenyl in there, phenyl propionate, you see the phenyl in there, parahydroxybenzoate, and parahydroxyphenyl acetate. These are all phenol compounds. If these guys are low, the gut bacteria are low. Pretty cool. I wish I had known that 20 years ago. There's several thousand patients that walked in and out of my clinic, and I didn't know this, and I didn't diagnose them right. Okay, so if you see a pattern of lows, they don't all have to be low. You see a pattern of lows here, where there's, let's just be real here. Let's say there's maybe 3 that are low, and then a couple that are in the middle, But if you see a pattern that's trending low, this person is lacking polyphenols. And if you give them polyphenol supplements, you'll crank up and improve their microbiome. If you get them to eat polyphenols in their food, obviously that would be even better. But we're talking, about interventions now in addition to diet. Obviously, if you get them eating healthy food, that's going to happen too, okay? So again, just to refresh what we're actually looking at process-wise here, with the dietary fiber to fat, right? There's your fat, your butyrate, your short-chain fatty acids. That's stimulating the hydrogen producers. That's stimulating the hydrogen consumers. The hydrogen producers continue to grow, and then the cycle just keeps on going. Okay, so that's the process with dietary fiber. And then this is how it looks on a lab. We're measuring short-chain fatty acids. You can see them right here. Butyrate. They do the total, and then they do the percentages. Again, I talked to like every major lab director about this. The percentages here are meaningless. There was a time years ago when they thought that it would help to look at the percentages. This has been totally discredited, but most of the lab companies still print these out because people are just used to them. But there's no science behind this at all. So we should just ignore the percentages. But these markers are still really important, the actual amount of butyrate, right? So if butyrate levels are low, You got to think about how you're going to get butyrate levels up, because you basically have a situation where there's not enough energy for the intestinal cells. Okay, we talked about this already. So then let's think about the short chain fatty acid producers. That's the group number one. Group number two, the guys that make hydrogen. Group number three is the guys that consume hydrogen. So now let's talk about these hydrogen producers. Like, what the hell is going on here? Why is this even happening in our gut? You know, it seems a little strange. Okay, there's a really clear biochemical reason why. When we, human beings, burn energy in our cells, we make ATP, right? And if you remember back to biochemistry, when you make ATP, when you make energy inside the mitochondria, you've got all these extra hydrogens left over at the end of this whole process of burning up your fat or your carbohydrate. And what are you going to do with all these extra hydrogens? Well, we cram them onto oxygen to form water. And that's how we make energy. If you're wondering how important is this whole process, try holding your breath and see how long you last. Take a breath in and hold it. The reason why you need oxygen on a pretty regular basis is because if you don't have oxygen, you don't make ATP. And then what happens? Your heart doesn't work, your brain doesn't work. I mean, this is not like an optional kind of nice to have kind of thing. Like, you could be low in serotonin and survive your whole life in a really depressed way and not sleep. And I have patients like that all the time. They've been low in serotonin for 50 years. They're still alive. But if you're not consuming oxygen, game over, right? It's a very important basic physiological process for human beings. Now, there's these gazillion, billion, trillion, million, gazillion, tillion bacteria in our gut, right? And they say, most of the studies that you look at say there's more of these guys than there are of us, right? There's more bacterial cells than there are human cells. And what are they doing? The ones that we're talking about now are in the colon, in an environment without oxygen. But they're driving all these hydrogen molecules up too, right? So what the heck are they going to do with all their hydrogen when there's no oxygen? Their hydrogen molecules get together and form hydrogen, molecular hydrogen, hydrogen gas. That's how these bacteria keep going. They're binding up their hydrogen by putting it together into H2, right? Hydrogen gas. So this production of hydrogen is essential for these bacteria to survive as much as oxygen is essential for us to survive. Now, again, what's also kind of interesting is this hydrogen then is the fuel supply for a whole other group of bacteria. So in other words, the waste product of that group of hydrogen producers is consumed by another group of bacteria, which is kind of cool. That's why they're living in this kind of totally overlapping integrated way. And just like human cells use fat for fuel, butyrate, we keep talking about, is the main energy supply for the intestinal cells. And without that intestinal energy, without that intestinal fuel supply coming from butyrate, you know, you're going to have all kinds of gut problems. The system's just not going to work very well. Now, for some reason, this one came out really teeny tiny. Point is that there's benefits of hydrogen. Besides the fact that it allows these bacteria to grow and help each other, hydrogen gas itself, very powerful antioxidant, anti-inflammatory, helps with everything under the sun, from insulin to protecting your DNA and your brain. It's really important. Okay. So let's look at a couple other important things here. I know I'm skipping a few slides, but this is like a 3-hour presentation I'm giving in an hour. So microbiome, we know it's super important, right? It helps with everything from GI to immune to metabolic. And here's where the story kind of, the plot thickens a little bit. As we want to think about this layer here, this mucin layer here, I'm going to draw here. You see that pink stuff? That thick mucus layer, or sometimes people refer to it in journal articles as mucin. This mucin layer here is essential to protect the intestinal tract lining. It's not just a coating. It's not just like a bunch of snot that's covering over something. It's very active. There's all kinds of enzymes in here. There's all kinds of biochemical processes that are happening within this mucin layer. And if we lose our good gut bacteria, that mucin layer will shrink. And then what happens is we develop leaky gut, And the gut bacteria, rather than being held at bay by this mucin layer here, the gut bacteria come in direct contact with our gut lining and really bad things happen. Okay, so before the leaky gut happens, you'll have a thinning of this mucin layer. Okay, I'm going to say that again. Before leaky gut happens, the first step is going to be a thinning of this mucin layer. So I want to think now, it's all about the mucin and the healthy bacteria that maintain that mucin. If we can keep that going, there will never be a leaky gut. And the immune regulation and anti-inflammatory role of all this stuff going on in your gut is going to work well. Okay, so let's look at, we got to skip to my favorite one here. Where is it? Sorry, this is a little bit out of sequence. Well, we'll come back to it. That's okay. So here's another example of a doctor's data lab. I think we saw some Genova labs, some GI effects from Genova, GI map. Okay, here we go. Bacteroides, remember? Bifidobacterium, just starting to get familiar, hopefully. NG means no growth. Lactobacillus, okay? Some of these are hydrogen producers. Some of these are the organisms that help with short chain fatty acid production, right? Here's our Clostridium, okay? So you want to start to, in your mind, group these. Okay, that one does the hydrogen. That one does the short chain fatty acids. You can start to get a sense of what your patient might need to correct their microbiome, okay? And again, NG with this lab company means no growth. So lactobacillus is really low. You could simply give lactobacillus as a supplement, okay? NG here, Bacteroides fragilis, really low, not even present, right? No growth. You could give the person some support for that as well. And you can, if you memorize these things, there's only like 4 or 5 of these to learn, then you can have a sense of, which product you would give for which person. So again, soluble fiber, all the companies have different options, apple and citrus pectin, guar gum, whatever kind of fiber really floats your boat. Here's another version. This is a doctor's data test. You can see, again, they're measuring butyrate. So all these labs still report these percentages. They're totally bogus and not of any point. So just ignore the percentages. Look at this is still very important though, the amount of butyrate. In this case, this person's quite low, okay? But ignore the percentages. Again, the labs are just reporting them because it's sort of customary. And then if the person, member, is low on their organic acids, polyphenol markers, those markers that kind of slip through 20 years of my clinical practice, here are the examples of polyphenols that you can give to bring those back up. Grapeseed extract, green tea, classic, right? Blueberries, who doesn't love blueberries? Strawberries, cranberries, spinach, pine bark. I don't know how many people are eating pine bark, but a red grape skin, right? Resveratrol. Point is, there's tons of polyphenols out there. And we think of these as antioxidants because they are, right? But these polyphenols, by and large, most of them are very large molecular structures. They're just physically big. And human beings cannot digest them. We can't, they're too big for us to pull into our gut, across our gut lining. I didn't know this. Did you know this? I didn't know this. I didn't know this until a couple of years ago. I always thought that I was giving people polyphenols so they would get healthier because they would absorb them. Turns out the polyphenols are good for us because they're so large that we can't absorb them, right? But the bacteria live on them. So when you give somebody polyphenols, to a large extent, most of these supplements that we're using are actually helping the gut microbiome. All I'm saying now is that we can do that on purpose, okay? You can look at those polyphenol markers on organic acids. If they're low, you can give polyphenols in the form of a supplement to make it all work. And again, here are those markers that we've been looking at for years. Remember, benzoate, hippurate, phenylacetate, phenylpropionate. If these markers show a pattern of low, let's say there's something like this, couple, 3 of them are low, and the others are kind of mid-range to low, that patient needs polyphenols in either supplement form or in the form of food or both, and that will start to normalize their microbiome. Pretty cool stuff. If you're using the NutriVal test, it looks more like this. Same exact markers, okay? They're looking at polyphenols. It's benzoic acid instead of benzoate. It's hippuric acid instead of hippurate. It's the same exact markers though, right? Just slightly different names. And again, if you see a bunch of them high, there could be dysbiosis present, and you might want to do a little antimicrobials, or you might want to just use some ox bile or something else, or HCl to calm that down. But if you see a pattern of lows here, okay, phenol, there's our phenol, right? If you see a pattern of lows here, then you might want to think about polyphenol supplements to get that microbiome working again. And this is why it's kind of cool that, let me show you this thing. This is why this is kind of cool. So this prebiotic powder, that was my idea. I'm kind of proud of it. It was really Richard Lord's idea. It kind of inspired me. I'm like, what the heck? Like, you know, it's branded as a gut repair product, but it's polyphenols. Now, every company has polyphenols. They're usually just not branded as gut repair. And this one's kind of sneaky because we got some prebiotics in there too. But basically, you could just use like green tea extract or bilberry or, you know, resveratrol or other polyphenols, you know, that are not specifically designed for the gut. Okay, it doesn't have to be this product. I was just kind of showing off there because I think it's kind of cool. And it's just cool in the way that patients go, oh, is that sort of special, you know? Otherwise, if you educate them well and you're teaching them about fiber and polyphenols and you're showing them on the lab, hey, these markers are low, this means you need fiber. Let's get you eating it. Let's get you supplementing with it. Hey, these markers on organic acids are low. You need polyphenols. Let's get you supplementing with polyphenols. Let's get your microbiome, you know, up. And then identifying, you know, how to get all the you know, lifestyle changes figured out. So there's one last level to this, but I'm going to kind of skip through it, which is you don't want to forget about organ dysfunction, right? Stomach, pancreas, gallbladder, all that good stuff. Those are important as well. But I want to show you some examples first. We're just really primarily talking about the microbiome today, because I think this is the part that, you know, most of you probably already know that if, you know, your gallbladder is screwed up, you can give ox bile and those kinds of things. So let me show you some other tests here. So in my clinic, the way I do it and the way I do it in my mentorship training program is we start off testing for cortisol and DHEA, looking at the HPA axis, because I feel like this has a really strong role to play in human health, is basically the stress response. And then we look at gut-related problems. So again, GI map, GI effects, doctor's data, you're going to see these beneficial flora. Bacteroides, NG means it's low. Bifidobacterium +1 means it's low. NG for lactobacillus means it's low. Clostridium +4 means you have plenty of it. So this patient could use bifidobacterium and lactobacillus from a probiotic, and that should jumpstart their whole process, right? And I'll show you there's a few others that you should just know. And I'm going to show you here on the, just before I forget. So if you're doing the GI effects test from Genova, you're going to see these three markers show up. Now, they're not in red. I'm putting them in red to highlight them. So Methanobrevor-Smithii, Deep Hydra, and Akkermansia mucinophilia. So each of these is a little different. But what's important is if you see a Deep Hydra that's low, this sulfovibrio sulfur, this particular bacteria, if it's low, like it was on this patient, will grow back if you give chondroitin sulfate or some other sulfur compound. So Deep Hydra lives on sulfur, okay, as well as on hydrogen gas. So that's just something to know. If you ever see one of these labs, again, a GI effects, and you see a low Deep Hydra, give the person some kind of sulfur compound, like chondroitin sulfate or MSM or N-acetylcysteine or some kind of sulfur compound, and that'll bring it back up. And then the super important one here is Akkermansia mucinophilia. And that guy is not a hydrogen consumer. That guy, you can see in his name, mucinophilia, Akkermansia mucinophilia. I always say philia. I think it's actually phila, but I've heard people say it philia also. Akkermansia mucinophilia, that's probably a better way to pronounce it. That guy is in charge of maintaining the mucosal layer of your gut. It's mucin lover, right? Phila, like Philadelphia, city of love. mucin lover. So Akkermansia is chomping along the gut lining there, maintaining the health and integrity of your mucin layer. If this guy is low, you are screwed, okay? Because your mucin layer is thin. Remember, we just saw that picture? Thin mucin means leaky gut. So this guy is extra, extra important. And he or she, depending on how you want to categorize it responds really well to berberine, responds really well to cranberry extracts, and responds really well to inulin. Okay, so there's 3 ways you can help Akkermansia. If you see it low, cranberry, inulin, and berberine will bring up Akkermansia. And again, deep hydro, sulfur-containing compounds will bring it up. Those are just 2 little asides. I just didn't want to forget. Not so little though, right? And remember, the Akkermansia, let me go back to that mucin slide. The Akkermansia is important because it's the one, mucin ephylla, right? Akkermansia is maintaining this mucin layer here. That's so important. And so you can see if that mucin layer thins, then you get inflammation, you get immune activation, you get all kinds of catastrophic problems. And Akkermansia is just floating along in here. It's like the gardener. It's like a gardener on a golf course. It keeps the golf course grass look really good. Akkermansia is just floating around in that mucin layer, chomping on the mucin, living its own little life, okay? Keeping that mucin layer healthy. And its food supply, what it actually eats, is the mucin. It's recycling the mucin, okay, and keeping it vibrant. Just like a good gardener would put fertilizer on a lawn, right? Their Akkermansia is keeping that mucin layer healthy. So without the Akkermansia, you can see what would happen, right? Inflammation, tissue damage, all that kind of stuff. Okay, so we talked about that. Let me go back to the labs here. We got another example. Now, I'm not against killing things. I'm just trying to talk about something a little different tonight so that we don't always just only talk about killing things. And then, of course, if the organs are dysfunctional, remember, microbiome is part 1. Stage 2 is the organs are not doing well. Stage 3 is pathogens. So you'll see on these markers here, elastase is out of balance. You give pancreatic enzymes, right? There's problems with fat absorption. You give, ox bile. You get a lot of mileage out of bile, ox bile supplements. They're really, really, really powerfully anti-microbial, the ox bile supplements are. Again, butyrate is measured, but we're not going to be worried about the percentages. And let's look at another set of labs here. Oh, and then the third test I do with everybody in the training program and in my practice as well is organic acids. So an adrenal panel, a gut panel, and organic acids. And then for our purposes tonight, we can look at organic acids in relation to the gut section, right? Whoa, ha, look at that. So this one's kind of a no-brainer. We were just talking about DL means underneath detected limit. That is quite low. DL underneath detected limit. DL underneath detected limit. Low, 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 low. Okay, so all these markers here, let me circle the right ones. These are the polyphenol markers. Okay, and you see how there's a pattern of, this is kind of a little overly dramatic, but there's a pattern of lows. This person is massively deficient in polyphenols, massively deficient in polyphenols. Okay, and then my super cool prebiotic powder, it's like, try to say that 5 times fast. Prebiotic powder, prebiotic. Okay, just because I had this personal obsession with Akkermansia, because it's really, really important. It's not random. But in the prebiotic powder that's from Pure Encapsulations, God bless Pure Encapsulations, they actually listened to me and they threw in this, well, they did some research and they found this Akkermansia booster. Let's see, here you go. Let me highlight this so you can see it. This is super cool. Where'd it go here? So these compounds, well, here, the health benefits of polyphenols may be due to their effects on the microflora. These compounds are generally not absorbed, remember, because they're molecularly large, but pass through the GI tract where they are biotransformed to enhance bioavailability and support healthy gut microbial composition. In an animal study involving mice on a high-fat diet, high sucrose diet, supplementation with cranberry polyphenols, promoted healthy fat metabolism in the liver, insulin sensitivity, and cytokine balance. So good for your blood sugar control, good for your detox pathways, good for anti-inflammatory, right? While reducing weight gain and visceral fat around your tummy. It was also shown, this is a cool part, to markedly increase Akkermansia mucinophilia. I can't say that the right way, mucinophilia, okay? So polyphenols will improve these bacteria. You can get super specific. If you get a lab with Akkermansia low, you can use something that has this cranberry stuff in it, right? The cranberry polyphenols to crank it back up. You can also use inulin. You can also use berberine, and those are available pretty much everywhere, right? So that's a straightforward one there. Let's look at another case here. We've got another couple minutes. If you have questions, fire them out right now. I'll try to answer a few questions before we wrap up. So I always do an adrenal profile. I see this as super important because everyone we work with is stressed. And then here's another doctor's data test. And you can see again, NG is no growth. +4 means there's a lot of it. And you're thinking, is that a hydrogen producer or consumer? Is that one that has a probiotic I can use or one that I could use some fiber to get up, right? Do I need some butyrate? Do I need dietary fiber? What's happening with the polyphenols? How can I fix this microbiome as an initial step? Now, this person has endolymic stana and blastocystis. I still really like to kill stuff. So honestly, if this was my patient, I would probably give him antiparasitic, antimicrobial program for a couple months first. I haven't totally let go of killing things. I think it's kind of fun. I really do see people get better quickly when we kill stuff. So I very rarely refer out for antibiotics, so I almost always, would do it with the herbal antimicrobials. So we got those guys. So this person, you might actually do stage 3, right? You treat the pathogen. And then let's look at the organic acids section. Let's see what that looks like here. Oh, look at that. Oh, this one's all over the map. So here's these polyphenol markers are here. Couple are high, couple 3 are low. Ooh, that's a tough one. So it shows, it's a little schizophrenic here, isn't it? So it shows some overgrowth and some not overgrowth. I would skew towards the side of the high. This is probably someone who's got a little bit of dysbiosis going on, okay? Because you're not going to see much in the way of highs if the polyphenols are super low. So this is probably somebody who needs a little polyphenol support, but also has a little bit of dysbiosis going on. That's kind of a tricky one. That one's kind of right in between. Hopefully most of the time you're going to see that's going to be more clear. Oh, here, let me show you. Megan was asking about GI map. So here's a GI map. I think this is a great lab. I think David Brady's one of the smartest people I've ever met. If you don't know David, he's incredible. Naturopath, chiropractor, all around like guru of all things scientific. And Tony Hoffman, who's the other person that started this lab, he's been around since I was like 12 years old doing this kind of testing. These guys are like top notch. So this is a really great test. Diagnostic Solutions Lab, the GI map. Okay, and they do really good at we're not talking about pathogens, but if this was my patient, I'd be killing the H. pylori, okay? Totally, I would be giving the Mastica to kill the H. pylori. But here's the section on the GI map that we're talking about. Okay, Akkermansia, mucinophilia. You see how it's spelled there with the IA? Sometimes they spell it like that, mucinophilia. Sometimes they spell it with just an A, see? That's where I got that pronunciation thing. Bacteroides, we talked about that. Bifidobacterium, Clostridia, talked about all these. Faecalibacterium, Prosnitzi, Lactobacillus. So these markers are all here as well, okay, on the GI map. They're all sitting right there, right? And now you can start to understand what they mean, right, and how to treat them. Like you can treat low Akkermansia. How cool is that? If you see Akkermansia low, you can assume that mucin layer is all screwed up. And you can use berberine, that cranberry stuff, or inulin to get it back up, okay? And you're actually treating leaky gut by stimulating these good bacteria to come back. Now, not every company has the exact same ones, but everyone's merging towards having the same ones, okay? So that's the GI map. We talked about doctors' data, and let me go to some questions. We have a couple minutes here left. Do I use GI map? Okay, we just did that. Sounds like you treat in stages. Is it a problem just treating all stages at once? Absolutely not. If you're a little more advanced, you can treat the microbiome, the organs, and the pathogens all at the same time. So how would that look? Let's say you gave them a prebiotic powder just to get them started on the good bacteria growing. You gave them some ox bile for their gallbladder, right? That would be stage 2. And you give them an antimicrobial program for killing Giardia. So you could obviously do all 3 at the same time, okay? Starting 1, going to 2, then doing to 3. Would you see something on organic acids under fatty acid metabolism? Yeah, I had a case like that today. Megan just brought that up. I'll show you. This is a really cool case. I don't have the actual labs here, but I can show you what happened. Oh, a second, I'm in the wrong thing here. Here we go. So her question is about, so this section here under fatty acid metabolism, right? If these markers are high, it means you're not metabolizing or breaking down fatty acids for fuel very efficiently, okay? And there's really strong correlations that you can see with that and omega-3 and omega-6 fatty acids. In other words, if you're not able to metabolize your fats very well, you can have problems with fatty acids like the omega-3s and omega-6s. And I don't know, I haven't really compared enough of these to see how that relates to the short chain fatty acids too, because those are happening in a whole different mechanism, right? The short chain fatty acids aren't going through your mitochondria in the normal way, right? The short chain fatty acids are in your gut and they're just going into the enterocytes directly in the gut. So it's a little different mechanism than how we burn fat in other parts of the body. So I'm not sure how that would relate. And then a question from Alexandra about treatment for Salmonella. My understanding for Salmonella is it's self-limiting, it just clears itself up over time. But for sure, with the high Candida markers, we treat those with the anti-Candida products, okay? Is there a functional medicine protocol approach for H. pylori? Absolutely. I have a whole couple hour, at least an hour-long lecture on that. It should be on our YouTube channel for Sarah. If it's not there, then you can just let me know. We can email you a link to it. But we use Mastica, and I'll show you. I actually did a research study on this in my free time. So just because I could, where'd it go here? It's pulling up now. I did a research study. That's a couple of years ago now. We published it in 2016, and it was done. So in here it is. About 10 years ago, a group of doctors from the Mayo Clinic took my mentorship class. Pretty cool. I was on the ball during that. Sue Cutshall, Larry Bergstrom were 2 of the practitioners from Mayo Clinic that took the course. Sue is from the consultative medicine department. I'm sorry, general internal medicine department at Mayo in Rochester. Larry's the former department head of internal medicine at Mayo Rochester. Now he is in charge of the integrative medicine department at Mayo Clinic in Scottsdale. Anyways, heavy hitter people. And we did this research study together. I did all the treatments. We used all the same protocols that I teach in my class. And one of the really cool findings in here, if you ever want to read this, I can drag and drop it so you guys can download it. One of the cool findings, there were 9 patients that had H. pylori in this particular study group that I worked with, and 8 of them, we cleared the H. pylori, which is pretty good. 8 out of 9 H. pyloris we got cleared up. And if I put this in the right place, you guys can download it. I'm going to drag it here. If for some reason you can't figure out how to download the study, just email my office. I'd be happy to send you a copy of it, okay? So yeah, absolutely, you can get rid of H. pylori. We did it under the auspices of Mayo Clinic research. In other words, like, this wasn't some fake out thing. 8 out of 9 times we got rid of H. pylori. However, if you look at the study carefully, you'll see that we did adrenal programs as well as the herbals together, okay? Yeah, as long as whatever H. pylori product you use, as long as it has 1,000 milligrams of Mastica 3 times a day, that's what you want to do. So let's see, if you have a copy, you should be able to see the Cutshall Bergstrom study, you should be able to download that. If for some reason you can't, I'll just ask my staff to email you guys all a copy of the study so you can see it. But it's pretty cool. We did a lot of work. I mean, this was a year of my life. And we have all the results and all the charts and everything in here to show how effective this stuff really is. And so the study was an adrenal program and a gut test and the associated gut protocols. And out of the 25 women in the research study, 9 of them had H. pylori. And we got rid of it in 8. A bunch of them had different parasites. It's a really interesting little project sideline thing there. Okay. All right, I'm going to wrap it up because our hour is up. I hope this was helpful, kind of stimulate some thoughts for you guys. And we'll catch up with you next time. We'll be doing a lot more of these in the future. Okay, take care, everyone. Have a good evening.